Hi. So filling out forms is a solved problem. You read, you click, you submit. But what happens when this all the simpler task becomes starts bothering you? So imagine you have exams is completely for educational purpose. So imagine your teacher takes your exam in the Google Form sheet, and you and your friend are completely fed up doing the copy and search in the Google. So this is easy, but indeed it takes so much time. So why not automate this? And yeah, we are living in the agentic AI era, so why not automate this? So this is a walkthrough of my project called FormAgent. So a local identity aware automation system with the capability of searching web searches using DuckDuckGo API. The architecture is deliberate separation of concerns of the two languages. So the client is powered by Python. So this is a client, and the MCP server is powered by Go because of the ca- capability of Go routines and handling threads in the fingertips of the Go. So what happens is actually Python owns the DOM. It scrapes the structure. So yeah, so it scrapes the structure, navigates pagination, and writes back into the DOM after answered are resolved. It does not decide anything. So basically I have scraper which is powered by Playwright, and the form filler which is again powered by Playwright, and a doc ingester. Basically this form agent can be used for your filling your uh, like roll number and your name and your email and your phone number. So that is why a doc is ingested in the resume as a resume. So as you can see, this is a personal info in the doc. So one can put all the details of there, and then it can be passed to the Python. So this is a MCP client, then it is passed through the Go server. So Go owns the intelligence layer, three tools exposed over HTTP: a DuckDuckGo scraper, which is the tool which is called search, an Ollama LLM client. So Ask LLM is the tool for that, and a state and an answer ranker. So the tool is called answer ranker. Basically, the key engineering decision here is the concurrency design. We are running a 3 billion parameter model, that is Qwen 2.5, and model locally and on a constrained hardware. So basically I have a basic rig. So it's a 3050 4 GB VRAM. So natively hitting it with 25 parallel requests cause out of memory and context tracing. So why not use the Go and semaphore effectively using Go? So basically here you can see it's a resolve batch function, and it uses three Go functions. Yeah. So it uses a Go function which called resolve done, which is again fires two Go routines. So basically, so I have used a buffered channel called SEM, which is a semaphore, and it is of size concurrency. And in the main.go, you can see the size I have kept is two. Let me check. Yeah. So yes, so resolve batch has jobs, which is a channel, and then we have two for the concurrency. So earlier it was three, but due to my hardware limitation, it has kept as two. So this is a classic semaphore a pattern in the Go. So three fields resolved at a time. Each field fires two Go routines simultaneously. So resolve done is basically that those handling those two Go routines. First one is this, and the second one is asking the LLM params and then searching the LLM params. So two are handling. One is asking the LLM about the queries, and second one is handling about searching about the params. So in the DuckDuckGo context. So at peak, that's six concurrent inference requests, and those are enough to saturate the model without crashing it. One of the major drawback was the scraper was working. Yes, so the scraper was working without any profile. So earlier, whenever this agent would run, this would fire a stateless Chromium browser. So without any without any profile. So, but we need a profile, right? So, in for example, I said in exams you would you can use this tool as for cheating, and then you can basically use your profile uh, to basically fill as mimicking yourself, right? So then there comes a Chromium DevTools Protocol. So basically, it runs on the port 922, and most of the automation tools miss this critical detail. And as said, like Chromium opens a fresh browser, no session, no identity, no email record. So launching this CDP, Chrome DevTools Protocol, we attach our existing Chrome instance over a local debug port, same session and same cookies and same Google account. So when this form submits, it records your name instead of an anonymous identity. So if in the README of the Python client, so here we have UV run Python main and the form URL, and then we have use CDP, a quick dry run. And so I will show how this exactly works. So we have CD client, we have CDMCP server, and this one for running the instance of the Chrome developer DevTool protocol. So this, as you can see, this opens already signed in me. So this would take a time. Yeah, so this runs, and if I say hi, so yeah. So let's quickly run our server. For, yes, so the server starts running, and we have in our Python, so we would to run use CDP, and then we hit enter. So yeah, so this starts scraping the form, and you can see it's quickly scraping all the questions include and along with the answers. So as we can see, yeah, so as you can see, this is resolved in 25 fields and answers perfectly. And yeah, we have nothing to do. Okay, so here comes the things. Okay. The form has been filled, and here you have not two options. Either you submit or you press enter in the terminal. So go and check our answers. So okay, everything was right, and we have sip of desert, yes, camel. So everything is correct, and nothing to change. So I did a submit, and you can see it it does this in 75 seconds. So basically, we took time in just doing here and there. If we haven't done this and quickly press enter or submit. So the least time I got was around 35 seconds or so for filling. And yeah, so this concludes the working and the walkthrough. So now talking about the trade-offs. So every architecture decision has a cost, which means I chose a 3 billion local model over a cloud API. That means the hardware constraint and concurrency and occasionally weaker answers on the general knowledge. The gain is zero data leakage. Why to use DuckDuckGo? So DuckDuckGo is a free search API. No snippets on some results, and the gain is no cost, no rate limit, no no key management for a student project. So I chose Go for intelligence layer over pure Python. That means a two-process system with an HTTP boundary. The gain is true OS thread concurrency for IO-bound LLM calls, something Python's GIL, global interpreter lock, cannot give you. And I chose CDP over persistent context for profile path launching. Basically, that means the Chrome must already be running, and the gain is you get your actual authenticated session with zero additional login flow. It's a form agent, local, fast, and identity aware. So thank you for watching this video, and give a star if you want. Thanks.